we're going to start things off. So it should be all review. If you look right here, they've given us a chart. This chart matches up with those shapes above. Oh my goodness, I can't make my screen small enough. There we go. So if you look at this chart, it says RS equals. What that means is if you drew a line from R to S. So if you drew a line from R to S, how long is that line? In this case, it's 2.5. And I know you all know how to do that. It's just a matter of can you read what it's saying. So RS means draw a line from R to S. How long is that line? So I look at this one, ST means draw a line from S to T. How long is it? It's also 2.5.
How is that 2.5?
Yeah, it's not to scale very nice, is it? I'd say it's a little longer. The next one would be from T to P. So if we drew a line from T to P across the bottom, that would be 3 centimeters. From P to Q is straight up, so that would be 2 centimeters. Mine goes off my page. Is yours on your page?
1.5.
1.5? Q to R? It might be on the next page. I'm sorry. No, yours is good. Yours is good. Only mine edited over. Okay. That's how you read line segments. Now let's talk about similar shapes. There's two terms that you guys have probably heard at some point. There's congruent shapes. There's congruent shapes and there's similar shapes. Congruent means the shapes are the exact same. Similar means that it's been blown up to get bigger or shrunk down to get smaller, which is what we did yesterday. We took shapes and we did scale factors. We made them bigger, made them smaller. If a shape has been made bigger or smaller, all the angles will stay the same. The angles is like this gap in here is 90 degrees. That means this gap should also be 90 degrees. And if I look, all of my shapes, all my corners actually do match up. This one's 90, this one's 90. This one's 110, this one's 110. This one's 96, this one's 96, this one's 154, this one's 154, and the last one is 90 and 90. Because all these angles are the same, I know these are similar shapes. It's just been made bigger. That means when I look at these lines, from R to S is 2.5, from R prime to S prime is 3.75, and those lines are similar lines. So they're the same line, just made bigger or smaller. We're going to fill out our chart below. So we're going to go RS, R prime to S prime. Prime is that little apostrophe. Is 3.75. It's been made bigger. That means from S prime to T prime is the same as ST, just made bigger to now be 3.75. T prime to P prime has been made bigger to be 4.5. P prime to Q prime has been made bigger to become 3. And the last one, Q prime to R prime, has been made bigger to become 2.25.
How?
Because.
I was just reading off my shapes. So I was matching up sides. I was like, this side is this side. Oh, I put the right number down, right? 4.5 and 2.25. I hope I put them in the right spot. I just recognize that this line must match up with this line because it's a similar shape, so those lines match up. Yes, sir.
Can I question?
Yes, sir. All right.
Actually, I'm making some.
Okay. Now when we're looking at those lines and we know which lines match up with which lines, We need to be able to describe, Reese, Luke, we need to be able to describe how those lines have changed. We describe how those lines have changed by calling it the scale factor. That's what we did yesterday. Yesterday we were calculating scale factors. What's the formula for scale factor? Come on, boys. What's the formula for scale factor?
You know, scale factor. It's like SCALE.
To calculate the scale factor, you take the new length or the new image and you divide it by the old one. And that will tell you how they're actually getting bigger or smaller, by how much.
That's right.
So when we look down at our chart, to calculate these scale factors, I would go 3.75 divided by 2.5. And that'll tell me how my lines are changing. In this case, I believe it's 1.5 when you calculate that. So this shape is actually changing by a scale factor of 1.5. And if you did every line individually, you're going to find that all of them have the same scale factor. So if I do ST, 3.75 divided by 2.5 is 1.5. If I do 4.5 divided by 3 for the next box, that thing has a scale factor of 1.5. And you'll notice that every single line had to change by the same amount. Just like we did yesterday, right? When we were drawing pictures, we took every line and we did a scale factor for it. We can work it backwards. So we can take pictures and figure out the scale factor by dividing all of the lines by the similar line. The last one would also be 2.25 divided by 1.5 is 1.5. All the scale factors are the same. They have to be in order for it to be a similar shape. If it's not, if one of these wasn't 1.5, then I wouldn't have similar shapes. The angles, we'll talk about how to read an angle. The angles in similar shapes should not change. So when I look at this, and I look up at my shape, angle P, which that's what this means. This thing means angle P. Angle P is right here. It's the angle at corner P. It's 90 degrees. Its corresponding angle is the angle P prime. If they're similar shapes, the angle should be the same. If the angles are different, they're not similar shapes. If we look, angle P prime is 90 degrees. Angle P prime, 90 degrees.
I see what you're doing.
So it must be the same shape. And I have to do that for all my angles. So if I go to fill out my chart, angle Q, if I'm looking at my picture, angle Q is 154 degrees. The corresponding angle, the one that matches up to it, is Q prime. It's also 154 degrees.
So we're going off the small one first?
Small one first, big one second. Angle R is 96 degrees. Angle R prime, which corresponds to it, is also 96 degrees. Angle S is 110 degrees. Angle S prime is also 110 degrees. And our last one, angle T. Angle T is 90 degrees.
Mr. T.
T prime is also 90 degrees. Yes, sir. So our rules are right there. If you have similar shapes are called polygons. If you have similar polygons, similar shapes, the angles must be the same. The sides must have the same scale factor. That's called proportional. They've grown by the same amount. Same scale factor. Gentlemen, you got to participate. Stop distracting.
On second page.
So the angles are the same, scale factor is the same. If you have that, you have similar shapes. So if I look at this question right here, which is going to come up on a test, and it says, determine if those are similar. It says, determine if the two, they say quadrilaterals, that just means shape, are similar. The way I check if they're similar, the first thing I do is I check their angles. Are their angles all the same?
Yes.
Yeah, they're all 90s, right? 90, 90, 90, 90, 90, 90, 90, 90. Those are good. Next thing I check is the way they grew or the way they shrunk the same scale factor. So I need to do the scale factor for this line turned into this line. Scale factor equals the new side divided by the old side. So for us, 21 divided by 30 is what you're looking for. Yep. If you put that in your calculator, I think you get 0.7. Yeah. So the scale factor for the left side is 0.7. Now check the scale factor for the other sides. So the new shape's the one on the right. Yeah, because see the arrow's pointing? So old pointed to new. The scale factor for the bottom has to be the same. If it's not the same, they're not similar. If it is the same, then they are similar. So I do scale factor of that bottom line is the new line divided by the old line. 18 divided by 35 is 0.51.
Right, didn't they rotate that shape?
No, they didn't rotate it.
Looks like it.
It looks like it, but what they did was they multiplied one side by a scale factor of 0.7. They multiplied the left and the right sides by 0.7. They scale factored the top and the bottom by 0.5, which is a much smaller distance. So they took it and they shrunk it and they shrunk it. But they shrunk it this way more than this way, which is why it looks like it's turned, but it's not turned.
If you do rotate it, then it is similar.
If you were to spin it like that,
Yeah,
it ends up being similar.
because it looks like they rotated.
Hot
They
garbage.
popped
Because
it
you
up.
do the two long sides versus the two long sides and the short sides.
I don't understand how they got 21.
18 divided by 30 is
18 out of 35.
0.6, and then 21 divided by 35 is 0.6. Wild.
Yeah, see?
They did rotate it and shrink it. We're not going to rotate it and shrink it. We're just shrinking it. I never even noticed that. I don't know if that's a massive coincidence or not.
There will, in the other courses that I've had, they do.
They twisted it and did a scale factor? Okay, I'm not doing that. You don't need to worry about that. So just compare sides. Because it's all 90 degrees, then I'm not worried about it. If this one, for instance, was flipped around, then I'd worry about it. Because these angles have to do with the corresponding angle. But these angles are all corresponding because they're all 90s.
Yeah, I'm smart.
You're smart. Yeah, Jordan.
Well,
Yes, sir.
I've done this last little bit.
So you've seen it. You've seen it once or twice.
Well, when you've done it a lot.
For us,
Easy, but
we're going to say these are not similar. Why are they not similar?
Because one of them is
The angles are gonna say.
The angles are the same.
the lengths of the same.
Of course, the lengths are never going to be the same.
Yeah. They're different numbers.
Yeah, they're always going to be different numbers.
Well, they should be the same then if the angles are the same.
Yeah.
Yeah, because you talked through the whole first half of this lesson.
I've done all the work.
Okay, then explain the answer.
Well,
Why are they not similar? They're not similar.
well, I don't know. They're different. They're different things.
Because you talked through the whole part, that's why I don't know. To know if they're similar or not, we compare scale factors.
Yes.
Scale factor is the new one divided by the old one.
Yeah, and I got all this.
I'm matching up this side with this side, this side with this side.
Oh, I thought we were talking
Oh.
about one underneath it.
But that just shows you more.
I wasn't. I know what we're talking about.
The scale factors are different, means they're not similar shapes.
Yeah.
If you look at B, and you want to know if B is similar or not, you need to check and see if the side lengths are going by the same scale factor. So when I look at the side here,
That looked really good on
I already gave it to you.
what?
You didn't get it?
Because you're on the bracket.
If you look at this one, 17.3 matches up with 9.4. You need to calculate the scale factor of those sides. The scale factor equals the new image.
Divided by the old.
Perfect. And what does that equal?
Without my calculator. It equals 0.543.
Nailed it.
I got you. See, I got you, Kennedy. I got you.
Holy
I got you,
Toledos.
teach. Hey, ladies, we gotta pay attention.
Thank you.
it. What you teach there?
Yeah, I thought I did too, but then he schooled me. He schooled me right in front of everyone.
If you want to check the next one, so if you look at the bottom, you need to check that scale factor. Do the new, which is 18, divided by the old, which is 29. If you put that in your calculator, you get 0.62. 0.62, it will round it to be 1. So did this side grow by the same amount that the bottom grew by? In this case, they shrunk. So did it shrink by the same amount? Were the scale factors the same? If they're not the same, they're not similar.
See, now I get that. Now I get what you're saying.
Even though the angles were similar in this case, right? Like they said these angles were the exact same. The side lengths did not grow by the same amount, so it doesn't count.
Is there going to be an example where they do?
I think the next one does.
Office.
Yeah, C is.
So if you look at C, if I say, are those similar or not, take one side, which I'm going to do in red, do the scale factor, 40 divided by 48. And you get 0.83 repeated. Then do the bottoms. The scale factor of the bottom is 20 divided by 24, which is 0.83 repeated. Those scale factors are the same. And if you did the other sides, they would all have the same scale factor of 0.83. I don't need to calculate the other sides because I can kind of look 48 became 40, 48 became 40.
Yeah.
24 became 20, 24 became 20. So I don't need to calculate the other sides on that shape. That is an example of similar.
Oh my god, I see Pythagoras theorem.
I don't know what is 510. I was just
My other half is missing, so you can keep writing that down. I'll have to reload my document. On your notes page, try the next two examples. If they are similar, which is what it says, try to figure out what the missing side length must be. I have to reload my document and then I'll go over that. So if you want to try the next one,